welcome to When Memory Fights Back. My name is Jonas Sommer Nielsen. First, thank you to our sponsors. Without them, we wouldn't be here today. This talk will be an 8-year-old problem. I first ran into it when my parents got their first PC with 4 megabytes of memory, trying to figure out how to run games on that, optimizing high memsys and config, but all that jazz. In the intervening years, computers have just become faster and faster and faster. My work laptop can spot 128 gigabytes of memory and 3 hard drives, and it's still a laptop. You can throw everything at that. But in the last few years, moving to the cloud, we start having these memory optimization problems again, running stuff in VMs and containers and moving them into the cloud. And in my team, we use Azure Runbooks a lot. And here we have a limit on 300 megabytes of memory when I started writing this talk, at least. So anyway, a bit about me. I started out in year 2000 as a Windows admin. I spent a few years in computer science, and then my first run-in with enterprise companies was SCA, and that's an honorable mention here, Svenska Cellulosa Aktiebolaget. That's a global company, but residing here in Sweden. And this is where I first encountered PowerShell. I started with the videos, Jason Helmick interviewing Jeffrey Snower, and a lot of Don Jones videos, stuff like that. But 5 years later, Isa, my girlfriend, she's here helping me out, not dying of stress. She comes up to me and says, you promised me that we would go travel the world. And I said, oh yeah, great. So I asked my boss, can I take off for 6 to 12 months on a sabbatical? He said no. So I quit my job, and following Isa's example, we dropped the apartment and sold most of our things and took off to Japan. That was basically the plan we had, just go travel. We could stay in Japan for 3 months. And while there, I found out that PowerShell Summit was going to happen the month after we had to leave Japan in North Carolina. And somehow I convinced Isa, let's go there. I can be at a conference for the first time and see what that's about. So a few months later, I show up at PowerShell Summit, a very small venue, 100 people, 150, something like that. I didn't know anybody there other than the rock stars I just mentioned. And so the first day I sit down at lunch at an empty table by myself. And 30 seconds later, Jeffrey Snower just plops down to the chair next to me and starts asking, where are you from? And I was mind blown. So since then, I've been to as many of these conferences as I could afford. I spent my time in different companies until today, where I'm in KMD, working in the CCUE. We are handling cloud for a fairly large Danish enterprise. We are owned by NEC, that's 100,000 people in Japan. This is where this talk starts out. One day, my finance guy comes up to me and starts talking, and he has this problem that the cost reports from Azure, it takes a long time for him to ingest them into Power BI. And while talking through it, I found out, okay, so every month he receives 3 gigabytes of CSV files. That's 3.3 million lines, depending on the month, that he wants to ingest into Power BI. And it looks kind of like this. Very not demo-friendly, 55 columns. And going through this, we found out, okay, so he actually only needs the 18 columns. A file looks something like this. And what he's interested in is the cost and quantity. So the same line will repeat up to multiple times a day during the month, and he just needs the aggregate cost and quantity for the full month. So for the presentation purposes, I created this demo set, data set, where we will be looking for something like Kiwi phone. And here I find 7 and 6, so 13 overall. So that would be the result I'm looking for in this particular data set. So instead of thinking 18 columns in the output, we'll be looking at 2 columns just to do the presentation. And of course, the last thing, he would probably want this automated. Yeah. So demo time. My knee-jerk reaction was of course, this sounds like a PowerShell thing. Something import CSV, group by export CSV. Why not start there? And this was my first try. So just to show you my demo data here, this is the entire data set I'm going to present today. So let's see Kiwi phone. I find 2 lines of these, and 4 and 6, 10. So 10 is the expected output we will be seeing later on. Is this okay with you guys? Good. The scripts I'm going through will follow the same procedure. A few parameters, just getting the input path and an output path, just to see what's going on. And let's just start out getting a list of files. I will execute the script. So I have variables. So the list of files we're looking at, you see on the left, is just these 3 files. In the original, I was, of course, doing this on the pipeline, not creating variables on the way. That's just for the demo here, so it's easier for me to show what's going on. But let's pipe these files into, for each object, an Import-Csv. And if you don't know Import-Csv, it just takes a CSV file as input and returns an object for each line in the CSV file. So I had 55 columns in these CSV files, so I get nice objects back with all this data in a nicely formatted way. What does this look like? Let's see. If I scroll up here, I just get a bunch of objects. What you would expect. Piping that directly into group object, we can, and why, let me start. What I'm looking for is reoccurrences of each line. So if I pipe it into group object and just give it the properties of the columns that I'm interested in, product name, resource ID, it will create groups for me. And each group will contain an object, which is a list of everything in that CSV file. So there I'll have all the data for the group needed. Yeah. So if we look at our object coming back from group object, it already begins to look like something I can use. So I find Kiwi phone, and I see a count of 2. That looks like what I found when I just browsed through my data files. And for Kiwi phone, I get a list of all the objects. So out here, I will see costs and quantity being part of that object. Meaning what I have to do now is simply sum up for each of the groups and create some nice output. Again, we're continuing down the pipeline, doing a for each of this data. So what happens here is for each group I found, I will execute this part of the script. And I want to calculate for orange phones or orange TVs or banana phones. Let's calculate the total cost and the total quantity. And this would be a question of, of taking that group. I will taking the group and piping it to measure object and just selecting the cost property and returning the sum. Quantity would be exactly the same thing. Look at the quantity and return that. And now we actually have all the data we want. So just format it and output it to a new CSV file. This is a trick I hope everyone knows. Just create a new PS custom object with the format we want. So product name, resource ID, cost and quantity, and pipe it to export.csv. That writes to a file. Export.csv does the opposite of import.csv. Takes a bunch of objects, write them to a CSV file. I really like using import.csv, export.csv because they are consistent. They make sure your data looks good. They check quoting around stuff. If you input something that would break the quoting, import-export.csv will make sure this works. It's not the fastest way to do it, but it's very convenient and it's easy to see what's going on. But at this point in time, I have an output CSV file looking like this. And I took this back to my finance guy and says, is this what you're looking for? And he was, yeah. And he checked, calculated the total sums and total costs. Looks like what he had in the input, but now we have a file that is less than 100 megabyte, less than 100,000 lines. Remember, we went from 3 gigabytes and 3 million lines to less than 100 megabytes. So it's way easier to work with. So proof of concept, at least, was good. Just doing this on my local machine, I fairly quickly spotted that doing it in 5.1 took 10x longer than doing it in 7x. I didn't dive into this. I just realized that, the new .NET framework faster. And I ran this on my local box. It took 10-15 minutes the first time I ran it. I later noticed that it spent 22 gigabytes of memory. And I had to represent this somehow. Think of the bar going off 22 times that way, because the graph I'm showing is 1 gigabyte, which will make sense a bit later because I'm trying to hit 400 megabytes. So that was kind of it. See you later. No. We want to automate this. And in my team, we use Azure Automation because it's almost free. We have a setup where we just create, in my team, just create a PS1 file, put it in a folder structure and run the pipeline. And I get a automation account with Runbook inside. You can run PowerShell and other languages if you want. The caveats here is you can't spend more than 1 gigabyte of space in your sandbox. 400 megabyte of memory this day. I'll say 300 megabyte a lot because that was what I was up against a year ago. And it can run for a maximum of 3 hours. You should probably go less than that because you might get killed on the way. So Gruber versus Runbook requirements, that didn't go over well. Should we continue? Yeah, of course. This next part reminded me of one of my teachers in computer science. He always said, and now you get a good idea, or this is when you come up with a good idea. A good idea almost always resolves around creating some kind of data structure outside of your algorithm to help you calculate whatever you're doing, speed up things. And one of the go-tos here was a hash table. You all know hash tables, I assume. It's a key value pair. The nice thing about a hash table is you hash the key, so you can do lookups in almost constant time. Even though you put in a ton of data into the hash table, you still have really nice lookup times. And I'm trying to compare 3 million lines and figure out which ones are the same. So it made sense to me. And why not say the value could be a PS custom object containing my cost and my quantity. So every time I see a string, I can just compare. And if I have it already, I just update the cost and quantity. That was my next thinking here. But same overall structure, import CSV, do something, export CSV. So the script starts out the same way. I now create a hash table. And I execute version 2 of the script. So now let's loop through the input once again. Just take each file and import all the data. This happens basically the same as before, import-Csv for each. So everything we see down here is going to happen 3 million times. I need some kind of key that I can put into the hash table. And how do we create a key? My thought was, let's just take the 15 columns as a string and put that into the hash table. Which is straightforward. Just each of the columns. And here I separated it by underscore. It makes sense when your data is emoticons. I know underscore is safe. Don't do that in production. Yeah. Which means now I have a key and I can check the hash table. Does this key exist? If it doesn't exist, we end up here and we create a PS custom object with cost and quantity and just put in the current cost and quantity from this line and I loop. If I find the key in the hash table, I can simply update the cost and the quantity using a simple plus equals. I'm always, when I see plus equals, I have something in my head saying, don't do it, don't do it. But that's for lists. If it's just a number, integers, you're fine. This works pretty well, and it's easy to read what's going on. So when we get to this point in the script, I've been looping through all my data the 3 million times, and I have a hash table that now looks like this, which is pretty close to what I'm expecting in my output, right? It looks almost like what I had in the group, but it's even more cool because now I have cost and quantity already calculated. So all that's left is enumerate my hash table and spit it out into a CSV file. Which we have here. Create a PS custom object, put in the information we have. I split the key by underscore and put in product name and resource ID and cost and quantity. And now I have my output here. Yeah. This also ran pretty fast, and if I compare to the first version, it's the same data. The sorting is different due to the fact that group object will return your objects in the groups it created. The hash table will return them sorted by the hash function, so that will seem kind of random. Yeah. But the result of this was it looks the same, except that now we're actually inside 1 gigabyte of memory. So the bar is the actual size, whereas the one up on top is 22 times longer. So we just spent 21 gigabyte less memory just doing this tiny thing. We're still not there because we need to get under 400 megabytes. But this runs quickly and it worked pretty nicely. But the next step, this is probably where I spent most time just trying to figure out how can I optimize this. And if we step back a bit, the first version group by, why does that take up 22 gigabytes of memory? we have the pipeline, and we're told that when you put something into the pipeline, and it just streams through and out the other end, so you don't spend too much memory. But if you put a group by in there, it needs all the objects in memory to be able to do the grouping. So when you throw 3 million objects into the pipeline, you'll have 3 million PowerShell objects with 55 parameters on each, and that takes up a lot of memory. But the next version, it feels like I'm doing the same thing. I'm putting everything into a hash table. But what ends up happening is I only put in a new object every time I find a new line. And I know from my test that the output file would be less than 100 megabytes, 100,000 objects instead of 3 million objects. So just a tiny thing means that you're reducing the memory footprint a very big amount. Yeah. But why does it still take up a gigabyte of memory? I know the output is just 100 megabytes. And thinking through it and looking at the output, I realized that every line in this CSV file, the output file, was an average of 472 characters long. And my thinking was, it's just a hash key, so it's not being saved in memory. But I realized that, of course, I can get out everything I put into the hash, including the string that is the key. Otherwise, I wouldn't be able to create my output. So I'm still saving all that data inside my hash table. And how do I get rid of that? And at some point, it occurred to me I can just take the string and do another hash, just hash the string, then I get a new key. I was looking around for ways to do this, MD5 hash, or build my own hash. It seemed fairly cumbersome and slow often, until one day I realized that .NET, of course, has a built-in hash function, which means on strings in PowerShell, you can just do get hash code, and you will get a hash from your string. And this string is 10 characters long. So instead of 472 characters on average, I will put in 10 characters, or a string of 10 in length in my hash table. So let's try that out. Now the code didn't really change that much. For it to make sense, I need to save that data somewhere. So I'll put that onto my storage account in a temporary CSV file. So I'll create a CSV file that looks like my output, and an extra column that is this key that I put into the hash table. So start out by creating my hash table and a temp file, just a random named file. Now I run through each of my 3 million lines once again. Create the hash key same way as before, and if I find the key in my hash key in my table, I will just update cost and quantity on the hash table with this hash key. So far so good. In case I don't find it, I need to do two things, same as before, create a PS custom object and put it into the hash table so I can do my calculation. But saving the rest to the temporary file, create a PS custom object, that sounds familiar, with the hash key and the 15 columns that we need to save. And the rest is, like before, import the CSV file, create a custom object, and write it out again. This part does not take up any significant amount of memory. It goes pretty fast because import CSV and output CSV, they optimize the read and write. So that's pretty neat. And it returns a new output CSV file looking like what we had before. If we find Kiwi phone, I see the cost of 10. as expected. So now we are at 200 megabytes of memory. So that actually worked pretty well, except suddenly the script runs a lot slower than before. This is a made-up number I did with test data. I don't even think I have the real numbers with the actual data. But I realized that writing to disk 100,000 times, when you just call Import-Csv, you find out how slow that is. And how can we optimize that? Let's just introduce a buffer. So say, don't write every time. Save the objects in memory. Let 1,000 objects at a time, and write that to disk. Sorry. Yes. And now we're getting fairly close to something that actually works in real life. Now I have a hash table, a temporary file, and an output buffer. An output buffer is an array list, something we can grow without too much cost. And the rest looks like something we've just seen 2 times before. Create my key, my hash code, check if the hash exists. If it does, we just update the hash table. But the last part changes a bit. We now create the PS custom object, put it into the hash table, and instead of writing our temporary data directly to the file, I just create it here and add it to my output buffer. In the last few days, I learned that I can use the type system in PowerShell to void the return output from that. That will return the index every time you do it. Usually I did $null equal and something, but I think this looks nicer. Bruce validated me in his talk and said, you can do this, it's fast. So I trust him. And last thing, now every time we loop, we simply check what's the size of the buffer. Did I hit my buffer size? If I did, I flush the buffer by writing it to Import-Csv into the temp file, append, and then I clear my buffer. Now I have an output file, and I'll see the output of 3 and 4 is exactly the same because it's the same hash function I'm using both times. The thing with the built-in hash function in .NET is it will produce different hashes from every time you run PowerShell. So don't expect these keys to work from one run to another. But as I'm running everything here in the same context, it works out for me. It's pretty fast and easy to use. So. Yeah, and that actually reduced the time a lot, 1,000-fold at least, which now brings me to a point where I can run this in a runbook in the real world, and everything works as expected. So what's the takeaway from this journey? A 99% memory reduction. I think the interesting part for me was just the problem-solving process here. I'm doing no magic at all. There's Import-Csv, group by, and a hash table. That's all I'm doing in this code. You should probably be familiar with that. You can run this in, I bet PowerShell 2.0 will execute this. Maybe not as fast, but it will work. There's no dependency on modules or anything else like that. Just looking at what's going on and thinking, am I creating too many objects? Not trying to do anything magical with the regex or whatever have you. smart-ass things. I like this because it's easy for my coworkers to read the code. I can show this to anyone and they can read it and figure out what's going on. And I ran into the problem so generic because I'm using that much memory. I just looked at the task manager. In real life, you would probably start using measure command or go all the way and use Jakob's profiler module when you want to know what's going on and looking at smaller data sets. But yeah. Q&A time. Yeah. I found this old comic from some time around NanoServer where PowerShell girl shows up and saves the day. And I have an old sticker. It must be at least 8 or 9 years old. So for the first question, I will give the sticker. if it's a nice question. Yeah. Yeah.
It's not a nice question, so keep this. You are now writing stuff to a CSV file.
Yeah.
But you're running it in Azure Automation. Is there any reason you don't use like a Azure Storage table or other?
Just it's what we used to do. It would be way more efficient, but my. Oh, sorry. The question is, why don't you use something else than just CSV files and storage accounts? For instance, storage tables or database or what have you. My finance guy has been using a lot of the Azure APIs for costs, and they're kind of flaky, or at least they take a long time to produce results. And the longer he's working with this, the more we're moving towards just basics, saving CSV files, reading them. Yeah. Oh, yeah. I didn't think that far. I was just like, I have a gigabyte of memory I can save in my sandbox, so I just wrote to that, and it seemed fairly fast for this purpose. So I didn't want to over-engineer it. Yeah.
Considering that this is kind of a financial supported system, was there any kind of consideration about potential hash conflicts or that kind of thing?
I went over it and we discussed that, yeah, that's definitely a thing you should be aware of here. What I'm looking at is just simple reporting, and it wouldn't hurt too much. And summing up like this, the overall sum in my result would be the same. So I wouldn't miss any data. They might be put into the same category. So, but yeah, that there you should be using some other hash that is with less. Yeah. Oh, you get this if you come up and pick it up. Yeah.
In one of the last versions, you started using hash function, which is producing, in my eyes, a very short hash.
Very short hash, yeah. I bet I did at some point. Sorry, and essentially the same question. Sorry, did I see any hash collision using this very simple hash function that produces a very short key? And I'm sure I did. I did not check for it. We decided it would not break anything considerable in our case. He's using this data for a Power BI report showing simple stuff. But that is definitely something to be aware of. Yeah.
How do you import the 3 GB file into the Azure Automation system? For the memory and 1 GB of storage?
By luck, because Microsoft provides files that are around 600 megabyte in size. So I basically download one file at a time to my local storage, and then I overwrite the same temp file every time. So if they had produced a 3 GB file, I would probably run into problems. I'm not even sure how it would fix that. So, but then I would need to read it from somewhere else, definitely. I did try using Profiler, yeah. The first thing I learned using Profiler is don't do it on 3 million objects, because then you will see memory bloat for real. Yeah. So yeah, I did use Profiler, of course, and I wanted to have demos here with it. But it turns out when you create demo data like this and expand it, it looks nothing like the real world data in memory. So I opted to not include any of that. But it shows everything you expect. This is the line where you use all your memory, and go look at that. So Profiler is really a nice tool. Just not 3 million objects, cut down on your input, and you will get really nice results. Anything else? If not, let's, yeah.
Reporting some data into Power BI.
Not really a problem, just it takes time. Oh, sorry. What was the problem importing data into Power BI in the first place? Yeah, not really a problem. He's been working like this for years. He was just every month he has to show up and order this data and import it into other Excel if you want to send it to anyone else, and do the same trick as this, but manually in Excel. So he was just looking for something to speed up that process. And now he has an automated report on another storage account that they can just save. He doesn't need to be there anymore. So that was the main goal.
I assume you were also mostly testing this on your own laptop. Did you see any significant difference between this running on your laptop and running in Azure Automation, or was that comparable?
Yeah. Did I see any significant difference between running it on my laptop and in the Azure instance? I didn't find a good way of profiling it inside the runbook. I guess I could just install Profiler and try it out. I did not try that. I definitely see things going a lot slower. So when this runs in for real, it takes 45 minutes to go through 3 gigabytes in the runbook. It's not a problem. It's automated. It happens at 6 in the morning. Who cares? Yeah, as long as it's inside the 3-hour scope.
Did you run it in PowerShell 5 in Azure or PowerShell 7?
I did run it in PowerShell 5 the first few times. I don't think I got it up and running reliably in 5. So we just switched to 7 and didn't look back. Yeah. I see a lot of issues running in 5 in the old setup because you have a ton of modules imported. So you have the old ACET modules and Azure, what are they called? Azure something modules. Everything is loaded and they can't be loaded at the same time, and you just get a lot of errors in your output. And so since changing to 7 and the new structure where you can define what is loaded in a more structured way, that's what we're trying to use. It feels better. Yeah. You did good. Thank you.